Atif Rashid, thank you. It's a very small room. If you guys can, maybe with some hands, tell me who's like a developer here. Okay. What about like a marketing business leader? Anything like that? Okay. Entrepreneur. What about like a infrastructure person? Is there any infrastructure people? Okay. All right. Excellent. All right. Well, so yeah, my name is Atif Rashid. I'm a cloud engineer. For Google Cloud. The one thing about Google Cloud that's interesting is that it is just a presentation of internal Google services to the public. So a lot of the services that you'll find are just things that Google has been doing for years, and they package it up in a way that anyone can consume. What this talk is not about is I'm not going to go into ML theory. I'm not going to talk about the back propagation algorithm on neural networks. I'm not going to talk about who created those algorithms in the 80s. Like, all of that stuff is available online. You'll see a lot of really smart PhDs who can, talk about that at length. This is sort of brass tacks, street level, what you can do with the stuff today, which I hope you guys find interesting at least. This is really interactive, so feel free to call me out and ask a question or anything. We're pretty laid back. All right, so let's begin. So I have a bit of an agenda. I want to talk about Google just for a minute, just to talk about the amount of data that we have and what we do. It's something, right? I'm going to talk about machine learning at Google Cloud. That definition changes every day, but I'm just going to talk about what we have from a capability perspective today. Then we have an API tour that we're going to go on. It's just going to talk about machine learning APIs that we have that are prepackaged APIs that you can consume literally today. I'm going to go through a few of them, and I'm going to talk about some of the newer capabilities that will hopefully be coming out. Then I'm going to talk about a little bit about Bigquery, which is a data warehouse at Google. It's huge. But I'll get into that, and at the very end, I'll tell you why you should care. So everyone knows Google. You've used it a billion times. The one thing that I think people might not know about is the sort of the supporting infrastructure and the supporting software that they have to deliver all of their services. So it's a global supercomputer of sorts. They lay fiber on the ocean floor. They have data centers in the ocean. They have data centers that I don't even know about, right? So it's quite something. Just a few stats. Huge service provider, 3.3 billion searches a day, 1 billion active users on maps, 400 hours of video uploaded per minute. I actually think this stat is old. It's more than that. The list goes on. It's quite impressive. There's no hosting provider on the planet that could support Google's infrastructure. They say something like 30% of all internet traffic goes over Google circuits. And if you guys know anything about containers, we spin up something like 2 billion containers a week. All right. With all of that said, I want to drive home this one. Oh, sorry. Container is a construct where you can put an application in, and then you can replicate it and scale it. So if say for instance you have 10 people using this application, you need another container to get another 10, etc. We spend something like 2 billion of those sort of instances in a week. So just the whole reason I brought that up is, infrastructure is more about policy and security and design, right? All of this stuff about resource provisioning and reliability, focus on innovation. The infrastructure problem has been solved. The scalability problem has been solved. Just ask Snapchat or Pokemon Go, right? So just worry about your innovation, your coding, how you're building your product, and all of that other stuff can happen for you. So at a super high level, this is the assumption of machine learning. You have tons of data, you put it through some sort of magical process, and then on the other side, you get a magical result, right? This is not real, right? So machine learning is not a linear process. It is an exploration. You have to go through, like there's no project funding, there's no like exact amount of resource planning that you can do to figure out a machine learning solution. It's all exploratory, it's all stuff that you have to kind of learn and kind of pick up as you go, which makes it really hard for people who want to, invest, I'm sure. But the reality is that all you're really doing is putting it through sort of a curriculum, right? So you're collecting data, you're organizing the data, create some sort of model, and then you use machines to figure out the pattern to come out with a new model, right? So eventually, with enough data, you can sort of solve a problem, a very repeatable problem easily. What's machine learning at Google? So it's just basically learning from examples and experience. So you can take patterns, recognize them, use metadata to identify them, and then move into some sort of insight or glean some sort of value that's unique to you or your organization. It's an incredible opportunity, right? I mean, I'm not saying again, going back to this, right? It's, this is what the expectation is, but this, to get here, requires a lot of work. And it's actually really exciting because now you can solve problems that took a really long time to resolve in like a second. And it's the culmination of supercomputing and hardware and the software and the algorithms and the math. All of that has come together at some weird inflection point to make it usable for people. All right, so there's 3 types of machine learning users. Okay, so there's people who use the pre-trained APIs, which is probably 90% of people. I think everyone should start there. There's people who are data scientists who are collecting data actively and then moving through some sort of model to actually predict something from a data science perspective. And then there's actual machine learning engineers who are sitting there figuring out how to make better algorithms, right? This is not what I'm going to talk about today, right? Well, I'm going to focus sort of here, and then I'm also going to bring in different technologies from a Google Cloud perspective or a Google perspective and sort of string them together into a story that might make sense. All right, so what do we have? You can train your own models. I'm not sure if any of you guys have heard of TensorFlow before. So TensorFlow is great if you really, from a hobby, novelty perspective, really want to figure out some of this stuff. It's awesome. We actually have a hosted TensorFlow service at Google Cloud called the Cloud Machine Learning Engine. So now you can just sort of consume and use TensorFlow at scale at Google. But where I want to sort of focus on initially is sort of the pre-trained models that we have at Google. Are any of you guys familiar with these? Yeah? A few? Sorry, do you have a question?
Yeah, quick question about Cloud Machine Learning Engine. Does that let you spit out a model to train TensorFlow Mini by any chance?
Sorry, say that again?
Can you use Cloud Machine Learning Engine to spit out a training model
Yeah,
for
yeah.
TensorFlow Mini?
Yeah, absolutely. You can go on and play with it. This is actually fairly new. So this is something that came out this year, and it's maturing at I actually don't have any customers using this today. So this people are using in spades, right? So sorry, do you have a question?
Can you use a pre-trained model with TensorFlow?
Yeah, absolutely. So think of it as a layered cake. So you have metadata that you're gleaning from all of these APIs, and then you're pumping it into a data warehouse, and then you're kind of taking that data and you're saying, well, I want to do something new. So I want to say, predict traffic. So I have all of these signals from metadata that I'm picking up, and then I'm pumping it into my own model, which is something that I'm an expert in, say traffic awareness or whatever it is, and then I can pump it through a model that I created, and then with enough data and enough learning, all of a sudden I can predict outcomes in traffic, as an example, right? So think of it as a layered cake. Okay? So this is a Google Cloud plug, so sorry about that. So we developed our own TensorFlow processing unit. Oh, sorry.
Sorry, just on the slide behind us, do you guys actively use API.ai, or like what's the integration there?
Google acquired API.ai. Yeah. So, yeah, of course. So, yeah, this is like, sorry, I don't know how to turn that off. The hardware unit is actually something I think that's pretty cool. They built a custom GPUs are really good for machine learning models, which are really compute intensive. So rather than using CPUs, which are kind of like your regular purpose CPU, GPUs are better because they're faster and they're more linear in how they like compute stuff. So you're like, okay. So taking that a step further, Google built something called a TPU, which is specifically for machine learning. And think of it as like whereas a CPU would be a Honda, this would be like a drag racer, right? Like one of those cars that are just built for speed and maybe you can't turn, right? But it'll compute at like a really fast rate. So we are heavily invested from like a hardware perspective. The interesting thing about Google is we're the third largest CPU consumer on the planet, and we only build servers for ourselves. So we don't actually sell servers. We just have it. We build our custom servers in our data centers. All right. All right. So it's a bit of an API tour. I'm just going to talk about capability, and I mean, I could go through some demos and stuff, but you guys can sort of assume that this stuff works the way it does. All this stuff is available. You guys can play with these APIs today. There's a website where you can actually upload an image and get all of this stuff, but I'm just going to walk you through kind of what the APIs do. So we have something called the Cloud Vision API. It does face detection, not identification, just to be clear. So it can detect things like where your face is turning, where you're looking, whether you're happy, sentiment, Another one is logo identification. So I could take like a photo here, and if you're wearing a type of logo, it'll detect that metadata, and you can see that from like an API call. Label identification. So that's similar. So like this is a picture of an animal. It's a cheetah. All of a sudden, I need to know that it's a cheetah because I don't want to have to look at it to know it's a cheetah, right? Explicit content, OCR, landmark identification. These are all pretty standard. So just go through a few practical use cases. Say you want to moderate image content, so you want to limit spoof images, bad content based on what you can see from images. You can do that. You can do it at scale. So like again, scale is not a problem anymore. So you can have a massively scalable app collecting images real time and producing this stuff real time is just compute intensive, right? We use it for our safe search. Image sentiment analysis. So here you have a few friends. You can find out that they're smiling. You could see that they're happy. You can see where they are based on the image in the background. It collects all of that metadata out, and you can actually, again, store it, keep it in a database, use it. Emotional state, joy, sorrow, anger, right? So here in this case, you just want to have image metadata. So say, for instance, you have, I don't know, like all of your travel photos, and you forgot that you're a world traveler who's been traveling for now 20, 30 years. And you're like, oh man, I went to China, but I don't remember that trip. Did I ever go to this landmark? Well, now you can throw that directory into some sort of system, pump it through this API, and then all of a sudden realize, oh wait, I did. Check out image 342 in this directory, as an example, right? The other one too is you know, you can actually figure out, okay, well this is the viewing angle of this bridge, so maybe you're at this location, right? OCR, so I don't know if you guys have used things like those expense applications where you could take a receipt and take a photo of it and then send it up. And then sometimes if it's too blurry, they'll be like, can you take another photo, right? Well, what they do is they actually take all that data, put it into their database and validate the numbers versus what you're actually submitting in your expense. Real time, right?
For OCR.
Yeah, sure.
If I submit anything for analysis to your system, do I have to worry about that data being used for other Google products?
Great question. So any learning that you do with the Cloud Machine Learning API, you keep. So we don't collect all of that learning back into our API. All of that learning happens on our consumer products. So if you have an image and you're like, oh, that's whatever bridge, and you brought it in from cloud, that learning is yours. And then if it's like publicly available, then that learning is publicly available.
Okay, but what about, say, if I want to use OCR to extract a user's personal information from something like a credit card or an insurance card?
Great question. So PI, personal identifiable information for cloud, if you're building a custom cloud product, is your responsibility. So if you're building something that's collecting that type of information on Google Cloud, that's your responsibility. So if you are building a service that goes out and collects social insurance numbers, then like that's illegal, right? So we will never go into your application. We at Google believe in something called a no trust model. So between services, we don't trust. There has to be a certain level of encryption, a certain level of authentication before services can communicate with each other. Make sense? All right, so, this is a surprise. This is the new features they have. So crop hints. I mean, you know, I guess when you take a photo, it'll suggest that you crop it, I guess, and this is the recommendation that it might give you. Web annotation, so if I take a photo of, you know, that DMZ logo, and all of a sudden in my metadata, I can say that, well, that logo might match this thing we found on the internet, which might be the Ryerson DMZ. Document text annotation, so again, before it would be something like a receipt or a sign that you could recognize, but now it's like sheets of paper, like entire books you can take photos of, and it'll OCR it. All right, and that's one API, so we have a few more. We good? All right. So cloud speech, yeah, I mean, it's pretty straightforward. It recognizes languages, supports real-time conversion, inappropriate content filtering. It's pretty accurate, even in noisy environments. This is something they've been building for a very long time. All it is imagine I have this recording, and all of a sudden I want to turn it all into text for the sake of reading or whatever. I can do that conversion quite easily now. Again, global vocabulary, real-time buffered audio support, you know, noise cancellation, content filtering. Yeah, it's really the speech recognition part of it that's like requires the real neural network. Yeah, I mean, typing's great, voice is faster, right? You can say a text message faster than you can type it, like hands down. It's easier, it's more convenient, more importantly, it's more accurate. So I don't know if you guys have tried to record stuff and you're like, that's not what I mean, right? These days, it's almost like in line with you typing in an autocomplete text. It's that intuitive. It's built into all of our products. Call center, so this is a good use case, call center analytics. So imagine you call your service provider and you're stuck in a queue, and then you finally reach a customer service representative, and this person is rude to you and don't like them, or you're already frustrated, they make you more frustrated. I'm sure that's happened to everyone. This is something that you can use to convert that, right? So like from a real practical example, customer calls in, goes into the telephony switch, imagine it's a car dealer. You take all of that data, pump it into a database, and then run some analysis on it, and then all of a sudden you have people who care about it. So you have your CRM application that you use to run your business, you have some visualization to say, and you can incorporate this with other APIs. So you can say, wait, the content of this call converted to text, the sentiment of it isn't good. What's this call about, right? And launch a trigger. Other subscribers. Which leads me to the natural language API. So this API is something that Google has taught to read, right? So imagine, taking text from an image, converting it into actual text. What this does is it'll actually read the text, gain sentiment, understand it, and figure out kind of like what it means and what it's about. So imagine you're taking like a review of a cell phone, and you take that text, throw it into the natural language API. It'll tell you the type of cell phone it's talking about, whether it's positive or negative, talk about the context of where that review might exist, and on it goes, right? And you can actually combine it with other pieces. But yeah, so all it's really doing is gathering sentiment, understanding syntax. So you could even use it for grammar. It'll identify sentences, but long and short of it, sentiment is the real thing that it will grab. I'm not sure if you guys seen this yet, but Google Translate API. I'm sure you guys have all know about this one. This app, it's just an API, right? So you can take text, convert it over, and then to like 100 languages, right? So Airbnb uses the translation API. 60% of Airbnb bookings connect to people who use the app from different countries. So they can, if I'm booking something in whatever country, I can book it from Canada in English, but actually it was written in German, as an example. Is this too much? Am I a bit of a fire hose? Is this okay? All right, we're going to keep going. This is again layered cake. We're really going to move up here. So the one thing I'm going to challenge you guys to do is start bringing these APIs together. So we have the Vision API, which we all know about. It kind of gathers metadata. Speech API, it'll convert things to text. All of a sudden now, if I'm converting things to text, so say I'm using OCR and Speech API, I pump it into the Natural Language API, and all of a sudden I not only have the text, I understand the sentiment of the text, and now I can translate that text to any language, right? So it's pretty powerful when you start stringing the stories together, or the pieces together, sorry. Now more APIs. So this is where, sorry if I'm bombarding you here, but we have something called the data loss prevention, which is pretty cool. So long and short of it, you were asking about private information. So this at scale will figure out if you have private information coming through your application. So you can actually prevent it from, picking up any of these things that are illegal to pick up in these countries, right? At scale. And you can classify it, you can redact it, so you can actually like exit out, star it out. Let me see. No, that goes into the next section. So this thing is interesting because it not only does it for text, but it can also do it for images. So if I take a photo of a credit card, it'll OCR that credit card and figure out that it's credit, and it'll actually build a black box around it. And they're actually doing things around, if you take a video, it can blur out faces, things like that. This is where this API is eventually going. Okay.
Sorry,
Yeah.
are we supposed to ask at the end or now?
No, you can ask now.
Can you custom define what you want to reduct? Or is this like a set that you'll
This is a pre-trained set. The capability is growing. So images, text are pretty much what it's at. But then if you combine this with like things like the Vision API, then all of a sudden you can do more things. I know that doesn't answer your question. Sorry. All right. So All right, so this is kind of where I'm going with all of this. BigQuery. So BigQuery is a data warehouse, and it's a huge data warehouse at global scale. So you can pump in petabytes of data and glean sort of results from it in like minutes, seconds. We have customers using BigQuery to aggregate logs from all of their systems globally into here so they can figure out some sort of pattern for security. We have other customers who are collecting all of the financial trading data, and because of our scale and speed, they can glean like value from that data at a pretty quick rate, probably faster than most or almost all service providers. It's a good place to just go and dump data and play around with it, and there's a ton of integrations and connections. So here's some good examples. Statistical analysis. It's a good, if you're trying to monitor how people are consuming your apps, it's a great place to do it. Internal applications. So BigQuery, great place to dump data. We have integrations into a bunch of stuff. It's easy to set up. You can connect and directly dump data from all of your web endpoints into BigQuery. Not only can we do Google stuff, but we can do third-party stuff. So we have, like, say for instance, you have a customer, or someone's using Hadoop, or even something a little less new, right? There's things like Informatica, which it builds connectors. So you can actually go in and take those legacy systems and connect all of that into BigQuery while you're connecting everything else real time, right? And it can just ingest it as fast as you want. Firebase, which we're going to get to next, again, collects all of that telemetry sort of real time. So I'm going to touch on BigQuery for a second because it's important from an ML perspective. When BigQuery comes in and you have raw data, so you have data coming in from whatever endpoint, and it's ugly and you need to rationalize it. You can use different tools within Google Cloud to clean it up, and then you can just pump it back into BigQuery so you can use it for your reports, right? So it's not just a singular endpoint, like you kind of can bring data in and out as fast as you want. Well, not as fast as you want, but pretty damn fast. So I'm not sure if this is as relevant to you guys, but I don't know if you guys have used stuff like Tableau or Data Studio or anything like that. Excel, I'm sure you have. But what you want to do at the end of the day is start building these dashboards that help you enhance your business. So you want to be able to take all these endpoints in real time, know that I have this many subscribers, this many of them have been here for this long. Here's what happened while they were there, like all of that stuff. Those are the reports that you need to build, and you don't want to have cumbersome tools to build those reports. You want something that's easy to understand and use, which sort of fits into this category. So who cares about it? Probably your data analysts who start using these tools, your data scientists who are building all of your ML capability at your organization, who's building the machine learning, because again, all you're doing is popping data back in and bringing it back out. And your data engineers. So if you have stuff that you're trying to pull in from Hadoop, which is Dataproc, or if stuff that your data flow is something called Apache Beam. So what data flow does is it'll actually stream data as it's coming in. So if I do a query and it'll say, oh, this is the result of that query based on this timestamp, but then I run it again, and then now it'll be a completely different set of results because of data has been ingested, right? So that's what this is. But again, we're not here to talk about that. So that's BigQuery. Do you have any questions? Make sense? Okay. So sorry if this is like fast and furious, but it'll all come together at the end. We have a chatbot, API.ai, which I'm sure you guys have played with. If you haven't played with it, definitely look at it. It's pretty cool. All it is it's intense. and agents and results. So basically, a chat, it's not going to sit there and ask you about the weather and do all that stuff that Google Assist or whatever does. You actually have to build an agent, and then that agent has to have an intent. So say, for instance, I want shipping invoices. I have to build an agent that'll know about shipping invoices, and then I have to have a piece of software that has to understand that intent, and that will, in Google Cloud, pull it all out of my database, and then it'll rationalize it back to a conversation. Does that make any sense? All right. Think of it like a chat bot, except it's voice and chat, and it's specific to your use case. So if you can think of a reason why people might want to interact with your business using voice, then that's the piece that you would build. It's not something that would be abstract and nebulous. It would be something for your business. It's cross-platform. You can use it. There's all these really cool tools and integrations that are great. And now we're going to talk about Firebase. Does anyone know about Firebase? A few people? Okay, so imagine on Google Cloud you can build servers, right? And that's not that interesting. But then what Google started to do is they started building something called a platform as a service. So I can install software and they run it for me, right? And I don't think about all the layers below, they just run my software, right? Firebase is something called a mobile backend as a service. So they've figured out how to build mobile apps for iOS and Android and have figured out what most people need and have built an entire tool set to make it really easy for you. So if you are trying to figure out how to build a mobile app, I highly recommend you try looking at Firebase, because all of a sudden your time to value, or that MVP product that you're looking to build, has been shortened and condensed down to a pretty easy solution. So that's what this is. So this is the smarts for your phones and mobility, and it does web, but more or less that's what it does. So if you have stuff like instant messaging in your app, or there's a whole bunch of things. I'm not going to talk about Firebase. I just want you to understand that it's the mobile piece of it. All right, so this is where things get really nebulous, and I want you to start putting on your architect hat and figure out that these are all just Lego pieces that you can put together to build a really cool solution, right? So we talked about Firebase a bit. That's your mobile front end, right? We talked about, search, Google Assistant, it talks about chatbots and stuff. Nearby is kind of interesting. So nearby is the idea that you have a beacon, and that beacon will understand if a phone is in this room. So imagine if I had a beacon here, I could have all of you do a whiteboarding session on your phone, and then the whiteboarding session would appear on the screen real time, right? Or for gaming, I could have you all in the here playing a game, and then there's a game screen. I'm not a gamer, I'm sorry. On the screen that you could play together, right? And it can build high bandwidth connections with each other, and it's all a messaging, out of band messaging. So it's pretty cool. But again, just a weapon in your arsenal, right? So who cares, right? Atif, you've been here for a while now. You've been talking nonstop. Please shut up, right? Who cares? Why do you care? They certainly do not care. Here's why you should care. So I've talked about all of these different APIs and what they can do, but basically at its heart is it builds a signal for you in your process. So that signal will build metadata, which you can then understand. And if you can string together pieces of this process in a new and exciting way and collect that metadata, you can put that all back into a machine learning model, which will then help you figure out how to do it better. And that's kind of the crux of this conversation. I hope that made sense, but imagine every single one of these just a signal. and you're collecting a signal as part of your process. So I've come up with an app. I have an app idea, and you guys can tell me if it's great or terrible. So, I'm in a taxi or an Uber, and on the back of the Uber, they have those damn screens, right? And those damn screens have nothing that I care about, right? And I'm trying to figure out how to get a coupon to that person who's in the back seat of that car that is relevant to them. And on the back end of my solution, I have a bunch of analysts figuring out how to do it. And so far, I've been really unsuccessful. So every kind of coupon that I've presented, people have hated, right? How do I fix this problem, right? Well, I gotta find the right coupon. I have to learn from the interaction of the taxi ride, and then I understand the feedback. So they do click it, they don't click it, they hate the coupon, they love the coupon, they use the coupon. Here's what it would look like from a machine learning perspective, right? So my cab has a device which uses a messaging service that it actually just pumps data into this messaging service that is always up and always available and always working. And then I somehow transform it and pump it into my machine learning engine, right? Now this is a custom engine that I'm using, right? This is a database. So remember how at the beginning of the talk I was like, just worry about coding. Don't worry about database scale. Don't worry about web scale. All that's been solved. Spanner is a globally consistent database. And because we have that massive sort of bandwidth on the ocean floor, and we can figure out from the hardware all the way up to the application to make that database globally consistent. So it's like a solution to database scale, right? So I'm pumping data into that real time as fast as it can take it. Then I'm also pumping data into Bigquery, which then I do other things with, which does some analysis, which helps me with my model, which helps me improve my model. And it's like a cyclical thing. So every single iteration of that interaction, it's learning, and I'm building sort of intelligence around how I can get better coupons to my people, right? Does that make sense? Is it sort of? Not really? If there's any questions, feel free to interrupt me, because I, obviously strung this together. So it's just like, yeah, so that's kind of like the baseline for it, right? So this one, now I'm going to challenge you guys. This is like a little bit more a harder use case, right? So I call it the retail app. I am not a marketing person. I don't know anything about that stuff. What does the retail app do? So retail app kind of can figure out that on my phone, I run a search, I look at a video, and then I kind of move toward my desktop to do more searching and whatever, and then I get some sort of conversion, right? That's the process, right? It kind of is an iterative process that I need to figure out how to do better because it actually affects my bottom line, right? So what is it? I need to find the right product. I need to recommend the next product. I need to understand the feedback. And by recommend the next product is actually like you've bought the product or you've used the product or you're deeply interested in the product. So how can I deliver this with, again, all of those signals, right? So I can get image metadata, find popular logos, understand all of those metadata signals that I kind of like brought up here. No, not the cat. Right? So again, you're just building a pipeline of signals for your process that I'm now applying to like a real world use case. And I'm trying to piece that together. So here it's like, okay, well, I'm gathering image metadata, Vision API. Recognize popular objects, Vision API, right? Logos, limit fraud, data loss prevention, API. All right, history of user behavior. Well, that's all sitting in Bigquery. I could run a dashboard report. Current product metadata. Well, I have metadata on the product. I'm stringing it all together to kind of build a new sort of product understanding or an understanding of how people have come to buy this product. I can aggregate product reviews off the internet. I can have relevant follow-up items. So as an example, I have an app, my retail app. I'm walking into the store. All of a sudden, the chatbot on my API.ai tells me to go to this corner of the store to pick up this product, but wait, salesman 1 is sitting there because he knows that I'm there. So wait a minute, no one likes salesman 1. What happened? Like why is salesman 1, like why does it get all the way to salesman 1? And so I want a signal to know that, hey, wait a minute, I've detected a pattern. Logo, product association. I can go out and figure out what people are saying on social media. Again, aggregate all of that into Bigquery. I can change it to multiple languages. I think you guys get it, right? Where things get kind of interesting is, how I touched on Google Nearby? Well, imagine my phone has a beacon, and now, based on my solution, when I arrive into that retail store, my app will know I'm there, and then it'll go into Bigquery, figure out kind of what I care about, and start presenting me different feedback or different reviews of various products that I care about. And that's kind of like the, omnichannel customer experience approach. Oh, and this is for the data loss prevention. I was just playing around. You can classify. You can say that, hey, wait a minute, anything that's coming into my pipeline, I need to edit out or change because it's actually against my security policy. There's all sorts of machine learning use cases in every industry, right? So you guys can go, like I was just talking about retail, right? Like the one thing I was saying about the retail app is inventory. Wouldn't it be great to know inventory real time, right? Stuff like that. But I mean, manufacturing, travel and hospitality, financial services, all of it exists out there today. It's all patterned, it's all processed. How do you make it better? How do you improve? And this is my favorite quote. I hope you guys take it to heart. Rupert Murdoch, it's about the fast beating the slow. Again, you guys have all of these tools at your disposal. You guys can move mountains in ways that no one could ever do before. So, and that's it. Thank you.